My name is Takahiro Tanaka. I belong to Department of Biotechnology and College of Life Sciences in Ritsumeikan University. My theme is enzyme technology to make it possible for everyone to drink alcohol. First, please look at this TED Talk about enzyme.
Flavor is king. Flavor rules. I call it the flavor rule. Flavor rules. And you can get somebody to eat something that's good for them once, but they won't eat it again if they don't like it, right? So this is the challenge for this bread. We're going to try this at lunch, and I'll explain a little bit more about it, but it's made not only with two types of pre-doughs. This attempt, again, at bringing out flavor is to make a piece of dough the day before that is not leavened. It's just dough that is wet. It's hydrated dough. We call it a soaker that helps to start enzyme activity. And enzymes are the secret kind of ingredient in dough that brings out flavor. It starts to release the sugars trapped in the starch. So that's what enzymes are doing. And so if we can release some of those, they become accessible to us in our palate. They become accessible to the yeast as food. They become accessible to the oven for caramelization to give us a beautiful crust.
What do you think? This is an example of using enzyme technology. The man tried to make a new type of bread using enzyme technology. Next, introduction. Introduction. Enzyme is an important substance for life. If all enzymes vanished in your body, you would die instantly. This study shows one newly development to make it possible for everyone to drink alcohol. Next, I want to introduce two data about enzyme. First, enzyme is to help chemical reaction in your body. Second, enzyme is a kind of protein. Protein is made of many amino acids. In short, enzyme is made of many amino acids. Please remember two data about enzyme. Enzyme is to help chemical reaction, and enzyme is a kind of protein. Next, main body. I introduce the mechanism of decomposing alcohol. Decomposing alcohol means alcohol change to other molecular. When you drink alcohol drinks, some enzyme works and decompose alcohol. One of the enzyme is ALDH2. ALDH2 is a kind of ALDH. ALDH2 change acetaldehyde to acetic acid. Acetaldehyde is made from alcohol. And this acetaldehyde is a poison for human. But this acetic acid is not a poison for human. So, ALDH2 is an essential enzyme for decomposing alcohol and detox. However, some humans don't have activated ALDH2 by genetic difference. Activated ALDH2 means that ALDH2 working normally. Please look at this movie. I introduce two types of LDH2. First, activated LDH2. Second, inactivated LDH2. First, activated LDH2. If you have this enzyme, you can drink alcohol. Please look at this structure. This is activated LDH2. Second, inactivated LDH2. If you have this enzyme, you cannot drink alcohol. Inactivated LDH2 is this structure. The difference between this activated LDH2 and inactivated LDH2 is small. One amino acid is different. I said enzyme is made of amino acid. So in this part of amino acid is lysine at inactivated LDH2. However, activated LDH is glutamic acid. This is difference, only this point. However, only this, because of only this difference, some people can drink alcohol and some people cannot drink alcohol. Next, the solutions of the problem to make it possible for everyone to drink alcohol. This is two ideas. First, to supplement activated LDH2. If activated LDH2 works normally in the blood, acetaldehyde decomposes to acetic acid. In short, you can drink alcohol. However, the solution has a problem. Enzyme is a kind of protein. So, enzyme is decomposed in your stomach to amino acid. Then, the way of preventing LDH2 from decomposing is needed. The example is to use cyclodextrin. Cyclodextrin has this structure, circle. So, it can cover LDH2 and carry LDH2 to your blood. In short, you can carry LDH2 to the blood and you can come to drink alcohol. Second solution is to restore inactivated LDH2 to activated LDH2. I said some humans have inactivated LDH2, so they cannot drink alcohol. So, if LDH2 become active, acetaldehyde decompose to acetic acid. Now, first substance is used. I show one example to supplement analog molecular of ALDA1, ALDA1. ALDA1 is this substance, and ALDA1 changes inactivated ALDH2 to near activated form of ALDH2. Please look at this movie. I introduce ALDA1, ALDA1. This is the structure of inactivated ALDH2. If you have this enzyme, you cannot drink alcohol. This is ALDA1. ALDA1 binds ALDH and activated the reaction. So, ALDA1 restores inactivated ALDH2 to near activated ALDH2. However, near activated, so the new molecular is needed. Therefore, new molecular is needed to product. My idea is the analog molecular of ALDA1. Analog molecular means other molecular having similar structure or characterization. In short, the new molecular should be similar ALDA1. If the new molecular can perfectly restore inactivated ALDH2 to activated ALDH2, you can come to drink alcohol. Finally, conclusion. In this study, I show two solutions. First, to supplement activated ALDH2. Second, to restore inactivated ALDH2 to activated ALDH2. All solutions are based on scientific data. However, they have some problems. Please look at this table. And the most serious problem is that real experiments have not been performed. In the future, real experiments should be performed. How do you feel? I think enzyme is wonderful. If enzyme technology is advanced, your life must be better.